find power series representation. For 1 divided by square root of 4 minus x. What are we going to do? We're going to use the binomial series. For the binomial series, if you have function f of x, which is 1 plus x to power k, and k is any real number, by using the Maclaurin series, which says if you have f of x, it can be represented by the summation of the nth derivative of f at 0, x to the n, divided by n factorial. We're going to take the first derivative and evaluate function at 0, which is going to be k times 1 plus 0 to power k minus 1. Which gives you k. The second derivative at 0 is k times k minus 1 times 1 plus 0 to power k minus 2, which is k times k minus 1. You can continue this process. The third derivative at 0 is k times k minus 1 times k minus 2, 1 plus 0 to power k minus 3, which is basically k minus 1, k minus 2. And you continue this process and you see that the nth derivative of f at 0 is equal to k minus 1, k minus 2, k minus 3, and you continue this process and you end up with k minus n minus 1. So following the Maclaurin series, f of x is equal to the summation of the nth derivative at 0, which is k, times k minus 1 times k minus 2 times k minus n minus 1 divided by n factorial times x to the n start from 0 to infinity. But this guy here, as we talked before, is nothing but you have k choose n. K choose n is defined as k factorial over n factorial k minus n factorial, which is k times k minus 1 times k minus 2 dot 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 k minus n minus 1, and you continue this process. You end up with 2 and 1 at the end. Or you can write it as k minus n factorial divided by n factorial times k minus n factorial. But you can get rid of these two and you end up with the exact same quantity that you have here. So the Maclaurin series for this function 1 plus x to power k is written as the summation of k choose n times x to the n and start from 0 to infinity, or a simplified version 1 plus kx squared times k minus 1 divided by 2 factorial plus the rest of the terms. So let us go back to this function that we have here. This is our function 1 over square root of 4 minus x. Okay, let us follow this. This can be written as 1 divided by 4 minus x to power a half, or 4 minus x to power negative a half. Very good. So let us fit that here. I'm going to create it the way that I see something similar to 1 plus a quantity and simplify this as much as I can. Or I can just write it down as 4 plus minus x if it's easier to see it this way. I'm going to write this guy as parenthesis 4 open parenthesis 1 minus x divided by 4. And here you have all raised to power negative a half. So I just factor that 4 here. It becomes 4 to power negative a half times 1 minus x over 4 to power negative a half, which is nothing but 1 divided by square root of 4 times 1 plus negative x divided by 4 all raised to negative a half. Just compare these two. Here you have 1, 1. X, your x is now negative x over 4, your new quantity. So wherever you see x, you're going to substitute that with negative x divided by 4. Okay, let us begin, everybody. So this function, 1 divided by square root of 4 minus x, so far is a half. Let me use the different color. Is a half. And then here, for this guy, is equal to the summation of, right? You get the summation of, what is your k? K in this case, as we saw, is negative a half, right? So you're going to copy down negative a half here. Negative a half, choose n times x to power n. But what is my x? My x is now negative x divided by 4 raised to power n. My n starts from 0, goes to infinity. Very good. So let us simplify this as much as we can so we see the behavior. This guy can be written as a half times. So we need to plug in 0, then plug in 1, then plug in 2, and so on. See what do we have. If you plug in 0 for n equal to 0, you have negative a half, choose 0, and then you have negative x divided by 4 to power 0. Okay, let's see. Plus, when n is equal to 1, you have negative a half, choose 1, and then you have negative x divided by 4 to power 1. Plus, when n is equal to 2, we do the same process. N is equal to 2, negative a half. Let me just erase this one. Negative a half. Choose 2 and negative x over 4 to power 2 plus the rest of the terms. In terms is equal to a half. Let's open the parenthesis. Negative 1 divided by 2. Choose 0. This guy is going to be just 1. Plus. Then you have negative a half. Choose 1. Times negative x divided by 4. So you get negative a half back. Times negative x divided by 4. Plus, let's go to the next. You have negative a half times negative 3/2 over 2 factorial, and you get x squared divided by 16. And you continue this process. You can simplify this further, and your 1 divided by square root of 4 minus x squared can be expressed as a half times 1 plus x divided by 8. Let's see, here you have a plus 3 divided by, 3 divided by 8 times x squared divided by 16. So you get plus x squared, 3x squared divided by 128. Or you can leave it in factorial form, whichever makes more sense to you or easier for you to read. And add the rest of the terms to it. So why this is helpful? Because later on, if you have a crazy looking function, like 1 divided by, doesn't have exponent 2, 1 divided by 4 minus x squared, then you can use this expansion to find the integral or approximate the integral. So please note that. That's an important note. This series is important in the case that you want to approximate an integral, for example, of the form, the integral of 1 divided by square root of 4 minus x cubed dx. We don't have a technique to calculate this integral. So what we do instead, we can use this power series expansion, and wherever you see x, you're going to use x cubed to approximate the integral.